You've probably seen it before, right? A big, ugly crack running right up the side of a building. And you might think, they should patch that up. But what if I told you that's not just a cosmetic problem? That's a warning sign. It's a sign of a massive struggle happening deep underground. So let's dive into this hidden world of why buildings stand and sometimes why they start to fall.
I mean, think about it. A building is just this incredibly heavy thing sitting on the ground. So when it starts to crack or even worse, tilt, it's basically screaming for help. It's telling a story of some serious stress. So the real question isn't just what's happening. The real question is why? What's the root cause? What's gone so wrong deep down that the whole structure is in trouble? Well, that's exactly the mystery we're going to solve.
All right, so first things first. Before we can get to the why, we have to look at the what. We've got to be detectives here and look at the clues, the symptoms. These are the visible signs that tell us something is seriously wrong.
And here's the thing. All these signs are connected. They're all part of the same story. You've got the big one, structural cracks. And I'm not talking about little hairline cracks in your drywall. No, we're talking deep, jagged cracks in the actual brick or concrete. Then you might notice the building itself is leaning, tilting just a bit. These are the things you can see, but they're caused by two invisible culprits: uneven load transfer and this thing called settlement. Basically, the ground itself is giving way.
Okay, and that brings us to the absolute heart of the problem. See, those cracks and tilts? They don't just happen randomly. They're the result of a huge conflict, a total mismatch between the building and the very ground it's built on.
At its core, a lot of engineering is just a balancing act. It's like a constant battle of forces. On one side, you've got the building's weight, the structural load, which is just this massive, constant downward force. And on the other side, you've got the ground, the soil, pushing back up. Now, when those two forces are perfectly balanced, everything's great. But when they're not, when the building is pushing down harder than the ground can push back, well, that's when things start to go very, very wrong.
Okay, so let's talk about this key idea, settlement. Pretty much every building settles a tiny bit after it's built. That's normal. The real problem, the disaster in the making, is when it settles unevenly. We call it differential settlement. Just imagine one corner of your house sinking an inch, while the other three corners stay exactly where they are. Can you picture the incredible stress, the twisting and pulling? That is what literally tears a building apart from the foundation up.
And this leads us to probably the single most common and most expensive mistake in this whole process. It happens when an engineer puts a simple, shallow foundation, which is totally fine on good solid ground, on top of weak or mushy soil. It's literally like trying to build a castle on top of sand or mud. It just doesn't work. The ground can't hold it up, and that disastrous uneven settlement is pretty much guaranteed.
All right, so we've seen the problem, we know what causes it, so how do we fix it? Or better yet, how do we avoid it completely? How do the pros make sure this mismatch never happens in the first place? Well, it really all comes down to one golden rule: match the foundation to the soil. It sounds simple, but it's everything. If you've got solid ground, strong soil or even bedrock, a shallow foundation is perfect. It just spreads the weight out. But if you're dealing with weak stuff like soft clay, you can't build on top of it. You have to go through it. That's where deep foundations come in. Things like giant pillars that go way, way down to hit a solid layer, transferring all that weight to something that can actually handle it.
And this is the perfect way to see how it all goes wrong. It's literally a domino effect. It starts with one bad choice, the wrong foundation type. That one mistake kicks everything off. The building's weight isn't spread out right, which leads to that dreaded uneven settlement, which puts crazy stress on the building structure. And boom! That stress has to go somewhere, and it shows up as those massive cracks and the scary tilting we talked about at the start. One domino knocks over the next.
So as we start to wrap this up, let's just remember what this is all really about. Yeah, it's about avoiding cracks, sure, but it's so much bigger than that. It's about making sure the places where we live, where we work, that they're safe, that they're gonna last.
And really, this is the single most important takeaway. The whole game is won or lost before construction even begins. It's all about that homework up front, properly analyzing the soil, understanding the building's weight. If you get that part right, you're building something that will stand the test of time. If you get it wrong, well, you know the rest. When you think about it, a building can be an absolute architectural masterpiece. But if that connection to the ground is weak, none of it matters. The foundation is everything. It's that critical link. You can think of it like a handshake between the building and the earth, and you really want that to be a firm handshake.
So next time you walk past a huge building, or even when you're just standing in your own home, take a second to think about what's holding it all up, that invisible connection to the ground beneath your feet. Because a building is truly only as strong as its foundation. And it makes you wonder, right? Is it built to last?